Okay, Georgina. Um, as quick as we can go. I know I've talked about circles before, and there's two very important um, formula that you need to know about. So, obviously, actually can draw a circle. So here we go. So that's me hand drawing it. So if I've got a circle here, a couple of things that you need to know about, which you already know, and that is this dimension just here is called the radius. Okay, that's from center to edge, and from edge through center to edge, that entire length there, as you know, is called the diameter. So diameter. Okay, and the diameter is two lots of the radius quite clearly, and the center is there. Now these one last word I was going to throw in there is the outside length, and it is a length. If you were just to walk around this distance here, the perimeter, and because it's a circle, we give it a special name. If it's a full circle, and it has to be a full circle, then we call it a circumference. Circumference. Okay, so this entire circle here, that line, circumference. Now we've talked about this. What was discovered a long time ago, not by Pythagoras. Okay, even though it's pi, we're going to be using in a second. What was discovered was that if you get the diameter, and I might as well use a highlighter actually. If you get a diameter, so just look at the diameter, there's the diameter, it fits round the outside. So if you start here and lay it, so there's one diameter. If you stretched it around there, then you've got two diameters, and then three, and you're always left with a little bit. Now you know that it takes, and it was discovered that it is 3.141 dot 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 dot. And if we rounded this figure up, it is actually 3. Well, if you look on the calculator, I'll show you what the figure is. It comes up, and there it is. So we've got shift pi equals an SD 3.145 dot dot dot. Now even the calculator, it has to round it up here because this is what's called an irrational number. It goes on forever and there's no recurring pattern to it. So even the calculators had to round it off here, and that's quite accurate. But we're going to make it less accurate because we usually just use 3dp, okay, or 4 sig fig. So we're going to round it off to there. So this is 5 or more, so we always use 3.142. But to be fair, we tend to use the calculator pi button anyway. So that's what we're going to be using from now on, 3.142. Now what does this mean? It means there are 3 and a little bit, diameters make a circumference. Now this number here, as I said, it's a bit messy to write that. We prefer to write pi, 2 sticks with a cap, and you've already seen us use that before. So there's your first equation. Circumference is equal to 3.142 lots of your diameter, and we don't want to write that, so we write pi. Circumference is pi times d, pi times diameter. The d stands for diameter. That only works for a full circle, okay, for a full circle. Now we have done this in class, so I'm going to show you something else now. So that's the first equation that you need to know, and we use that for circumference. Circumference is just a length. It's not an area, it is a length. If I just scroll up and come back to that in a bit. Okay, let's just go back to black and tools and draw another circle. Okay, now when we're in class, we would have done this, and I'm going to whiz through it here, so it might look a bit messy, but here we go. I'll give it a try. Right, so there's your circle. Now what was discovered years ago was that if you cut this up into sectors, so there you go, I cut it up into 4 sectors. Well, what they did, they cut it up into a lot more than that. but we're going to cut it up into sectors like this. Okay, so you can see we've got 1, 2, 3, 4, 8 sectors. Okay, and we could cut it up again if we wanted to, and again and make these minute. Now, whoever discovered this all these years ago made these so they're really fine little slivers. Okay, and there was loads of them, but we're only using 8 of them at the moment, 8 sectors. Now, what this person did was then get one of these sectors, just one of them, and cut it perfectly in half. Okay, it's not a very good half, is it? I'm going to say. Let's see if we can get any better. There we go. And so I can show you what's going on. I'm going to shade it in one of these in that colour. Okay, and we're going to shade in the other in this colour. Okay, now a long time ago someone did this and cut these out, and I said a lot smaller than these. Okay, very fine slivers, very fine sectors, and they laid them out like this. Okay, so let's get this first one here. They laid it so the first section was just like that. Okay, let's get its colour. I think I used that colour, didn't I? I don't know. Let's look. Yeah, I did. Right, so they put the first one there like that, so that that was perfectly horizontal on this line here. That's perfectly horizontal. Okay, then they got one of these and left this one out for the time being, and they laid them one like that, another one like that, another one like that, and so on. It's looking messy. I'm trying to keep it as neat as I can. 1, 2, 3, 4, 5. They should all be the same. 6. That's badly done. 6, 7. Remember, there's 8 of them. Well, that's half of one, and then they realise they can just put the last half just there. Okay, and that colour I think we used is that one there. So they put the last little sliver, okay, just there. Now, if I just shrink this, I don't know if I can. That person did right. Okay, I can't do it. Right, so I've got that there. So we use these top and bottom, and that is perfectly horizontal. This last little line just makes it perfectly flat again. So we've got all of the sectors were laid out in this way. Bear in mind they use very fine little slivers. Now what I want you to realise is that I've got 1, 2, 3 and a half, so that's 4. You can see I've got 4 sections going down there. I've got 1, 2, 3. Let's do it again. 1, 2, 3 and 4 sections going up there. So I've got, that is a part of the circumference, and that is 4 parts going down there, and these are 4 equal parts going there. So going down here, this length here is half of the circumference, and this length here, we'll think about that very carefully. Okay, that was the center of the circle, just here, and that is the edge. There's the center, that's the edge. And what do we describe that as? Well, we describe that as radius. So that is the radius, okay, which is R. Now, there's half his circumference going down there, and this is the other half of all the circumference going up there. Now, we know from earlier, circumference is pi times diameter. But I told you before that we don't usually write this, but I did tell you before that the diameter is equal to 2 lots of the radius. 2 lots of the radius R. Yeah, 1 radius, 2 radiuses make the diameter. So I can replace that with 2 times R. And we much prefer to write that with the numbers in front, 2 times pi times R, so 2 pi R. We're going to write it as 2 pi R. That's what circumference is equal to. two lots of pi r. Now, if half of it is going down there and half of it is going down there, then if you halve that, 2 pi r, you're just left with pi r going down there. That length down there is pi r. Now, what you need to understand is if you use very fine slivers, this wouldn't be curved, it would be perfectly straight. It would make a nice rectangle. And you know, to work out the area of the rectangle is area equals length times width. Area equals length times width. Well, you know the length is pi r, so replace that. Well, let's rewrite it. L is replaced with pi r, and we times it by the width. Well, the width is the radius. So pi r times r, well, r times r gives you r squared. So there we have now got the formula, area equals pi times r squared. That is the formula for the area of a circle. We might be saying this is curved. It won't be curved if you're using minute little slivers. They'll be just little dots, and it would straighten this up down here and straighten that up down here. So there is the second formula that you need to know. However, again, this only works for a full circle. So you've got your first formula for the circumference, which is a length, and you've got the area formula, which is for a full circle, pi times radius squared. So let's have a look at those. I'll write those down. Circumference equals pi times diameter, and we've got area equals pi times radius squared. Okay, now if we're going to be looking at a circle, then if I just draw a circle out here, tools, shapes, and there's a circle. Let's just draw a circle. Okay, then if I give you this dimension from here to here, and I tell you that that is 8 centimeters, I have given you the radius. Okay, so we always put r equals d equals, and this just makes you think which one's been given to you. You were given the radius. Now, if the radius is 8, the diameter is twice as big. The diameter is 2 lots of those, so it is 16. I always tend to write this out. You don't get any marks for it, but it at least makes you think about which one do I use for which formula. So if you were asked for this length around here, the circumference, so A, if you're asked for circumference, you would write the formula, circumference, C, is equal to pi times diameter. Pi times, and the diameter is 16 centimeters. Okay, and the calculator will give us that as 16 pi. Now, as I said to you, pi is an irrational number. It goes on forever, so it's a lot more accurate to leave it like that, as you'll see. Look, shift pi times 16, the calculator will leave it as 16 pi. If you convert it to a decimal, it's been rounded because it goes on forever. The calculator is rounded, so this is less accurate than leaving it as 16 pi. It's a lot easier just to leave it as 16 pi. Okay, but if you did want it as a decimal, or if the question wanted as a decimal, not in terms of pi, and you have to round it to 1 dp, let's say, the answer would be 50.3 centimeters squared. But I'm going to leave it as that. It is that many. Sorry, not centimeters squared. It's a length. It's a length, so it's centimeters. Okay. Now B, if we were asked for the area this time, which is centimeters squared, you would use the area formula. Again, these two formulas, this one and this one, only works for full, complete circles. So pi times radius squared. So it is pi times radius. Well, that is the radius, 8. And we've got to square it. Now, if you do it on a calculator, you will end up with 64 pi. Okay, let me just show you. Shift pi multiplied by 8 squared. So the calculator must square the 8, which gives you 64. and pi times 64 gives you 64 pi. And again, it's a lot more accurate to leave it like that than having to round it to write 201.1. Okay, so we're going to leave it as 64 pi, and the units, because it is area, it is the space inside the boundary, the circumference, it's the space inside, it is centimeters squared. Okay, now these questions are going to get harder because you're talking about sectors. Now a sector, so I'm jumping straight to the last bit that you need to know about. The sector is a part of a circle. In fact, I won't draw it there. I'll just draw it here, okay, to give me a bit more space. Right, there we go. So the center is there, and this is a part of a circle. So let's say that this angle here is 20 degrees. And let's call this dimension here 14 centimeters. Now, there's two things. Let's work out arc. An arc, if it was a full circle, an arc is part of the circumference. So that is the part of the circumference. It's given a name called the arc. So arc, A-R-C. We can work out that by using the formula circumference equals pi times diameter. Now I told you, and I've been on about this all along, that this only works for a full circle. So we've got to imagine tools and shapes and circle. Oh, it's gone back. Right, we've got to imagine that this is a full circle. Okay, like such. So let's get back to normal. So that's a full circle. The angle around in a full circle is 360. So the amount I've got of this circumference as a fraction is arc length is equal to a fraction of a full circle, of a full circle circumference. That's the full circle circumference, and this is part of it, a fraction. If we wanted the whole thing, we would write 360 over 360, which is just 1. But we want just a part of the circumference. This angle here, just this fraction, it is 20 3/60ths. It is that fraction, this little bit of the full circumference. So it is 20 over 360 times pi. We know what that's 3.142, but it's a lot more accurate to leave it as pi, times diameter. Now look at this. That's the center. I've given you R or D. Which one have I given you? Well, from center to edge, I've given you the radius is 14 centimeters. That means the diameter is twice as big as that, which is 28 centimeters. So I will have to put diameter here, which is 28. So I can just type that straight into the calculator. So here we go. Fraction button, 20 on top, over your 360. So it's that fraction of a full circle. Come out, and then times by shift pi, times by 28. Press equals, oh, I've missed pi out, sorry, let's do it again. Fraction 20 over 360. Come out and times by shift pi and times it by 28. Let's start again. There it is. And as I said, it's a lot more accurate than rounding this up, which is 4.9, let's say. We much prefer to leave that. You'll be asked in the exam, in the test, it'll say, give it to 2 fig, 1 dp, then yes, you'll have to get that and round it. If it says leave in terms of pi, which is 100% accurate, leave it like that. So 14 over 9 pi, and this is, all you've done is worked out this length of this little curve, this arc. Okay, so it is just a length in centimeters. If the radius is in centimeters, this will be in centimeters. Okay, that is the answer. Now, if you're asked for the perimeter of this sector, well, obviously you've worked out this length, but you need to add on this length and this length. Well, that's a radius and that's a radius. So you'd have to do 14/9 pi, which is that length there, and you'd have to add on 14 and 14. You'd have to add on 28, and that's how you'd write it. 14 pi over 9 plus 28. 14/9 pi plus 28, lots of centimeters. That would be the full perimeter, outside length, all around here. Okay, I didn't ask that, I just asked for the arc, but some questions will ask for the full perimeter. Okay, so we didn't ask for that. Right, that's how you work out an arc. So it's a fraction of the full circumference, so we use fraction 20 over 360 times pi times the diameter, and you must make sure you use the diameter. Now you could work out the area. Okay, so that's arc length, and this is the area of the sector. Now area again uses this formula, A equals pi times radius squared, but that again is for a full circle. So the area is now a part or a fraction of a full circle, and times by pi times by radius squared. Now the fraction again, as you've just seen, is 20 parts out of 360. 20 3/60ths times by radius, pi times radius squared. Radius is 14, so I've got 14 squared, and it is that I'm going to type into the calculator. So fraction button, 20 over 360, come out, and times by shift pi times by 14 squared equals that, which is 100% accurate. Okay, and again, if you go around it, then obviously you go convert it in, you round it, but I'm going to leave it in that format. So it gives you 98/9 pi, and it is an area. It is the area of that, the space inside that, which is centimeters squared. Okay, and that is what you get for the area inside that sector. Okay, that's how you get the area. Okay, so I hope that makes sense. Certainly make a start. You should be able to do some of those questions now on those two worksheets.